All right, so these notes are starting to talk about graphing inequalities. So go ahead, title your notes 5-6, graphing inequalities in two variables. Remember we already did one variable is where it's just like x is greater than 3, and we do it on a number line, and we're like, okay, here's 3, there's 4, there's 2, here's how we graph it. Okay, so that's one variable. Two variables, though, is what we're going to focus on now. Okay, so again, we want to make sure that we're attending to precision with this lesson, being very careful in how we graph, and then we will be shading. So let's look at this. Okay, so first off, what are the steps to graphing an inequality? Okay, so over here, first step is that we want to arrange the inequality so that it's in slope-intercept form. So usually we have y equals mx plus b. Okay, for this, obviously it could be like y is less than, y is greater than, less than or equal to, etc. Okay, so the sign doesn't matter, but, you know, in that form. So let's say example. All right, step 2 is that you're going to pretend the inequality symbol is an equal sign and graph the line. So whatever the sign was, replace it with an equal sign, and then graph using the slope and y-intercept. Okay, we'll review that because I know some of us have gotten a little rusty. Okay, once you have your line, you're going to use a dashed line if the symbols are just less than or greater than, and then you'll use a solid line if it's less than or equal to or greater than or equal to. Okay, so that little line, remember we called these inclusive inequalities. Okay, so they include the points on the line, in other words. So we do a solid line, inclusive inequalities. Okay, I'll fix it. Okay, so once we decide what type of line to make, we're going to also then shade. So if it's like y is greater than 2x plus 3, then we're going to shade above that because it's the values that are above, okay, they're greater than that line. If it's less than or equal to, then we shade below, okay? And we'll see this in the examples. Okay. Second question here is how do we graph from slope-intercept form? So, wait, I forgot how to graph the line part. How do I do that? Okay, well, recall that for y equals mx plus b, m is the slope, which we would say is like rise over run. So this we either go up or down, and then the run we typically always go to the right, because if it's positive or negative, we deal with it with the rise, or fall, I guess. Okay, B is the y-intercept, which is where the line crosses the y-axis, so that's the point that we start at. Okay, we start at the y-intercept, and then we go up or down whatever the rise is, and then to the right whatever the run number is. All right, so go ahead, copy whatever you missed here, and then move on to the next example. Okay, so our first example here says to graph this inequality. The first thing that we need to do is rearrange our terms because right now it doesn't look like y and then mx plus b, right, with the symbol here. It's in the wrong order. So we want to rearrange. Okay, I want the y by itself, so I'm going to go ahead and subtract 3x from both sides. That's going to leave me with negative y. I didn't multiply or divide by a negative, so I'm just going to carry down the sign. So I've got negative y is greater than negative 3x plus 2. Okay, and then I need to get rid of this negative. So I'm going to divide everything by negative 1. Which will cancel that negative out, so I just have y. I divided by a negative, so I need to flip my sign. Okay. Divide by negative. Okay, so I flip my sign, and let's see, negative 3x divided by negative 1 gives me a positive 3x. Positive 2 divided by negative 1 would give me minus 2. All right, so now that I have my equation, I'm going to graph it. Remember, the y-intercept is right here, so that means b equals negative 2, or the y-intercept is negative 2, so I start my graph there. Okay, and then the slope is the number in front of the x, so that means my slope m equals 3, which I could think of as 3 over 1. So that means I'm going to go up 1, 2, 3, and then over 1. Okay, so that's my second point, and I'm going to connect those with a line. If I want to be more precise, I can do the slope again, so it's up 1, 2, 3, over 1. Okay, I kind of go backwards, make sure I have a lot of points, and then I want to use a straight edge to make this line. It's probably going to be bad, sorry. Good enough. Okay, so there's my line. Oh, but wait. This symbol is just greater than, which means it's going to be a dashed line. So let's back that up. So greater than sign means I'm going to do a dashed line. Okay, so between those points, I want to do little dashes. Or I could always go back to my line that I made and just kind of erase spots in between. Okay, if that's going to look better. Okay, but this dash line lets us know that the points on the line don't work for this because we want y values that are less than. Oh, excuse me, it's less than now because we divided by negative. So we want y values that are lower than the line. Okay, so we're going to shade. Okay, and let's do, so that means dash line, and it means we're going to shade below line. Okay, we want the y values that are less than the line. So here's where the line hits the y. We want the y values that are lower. So we're going to shade this area, and we just shade the whole thing, that whole side. We call it a half plane. Okay, shade that whole thing because it's the part that includes the y values that are lower than the line. Okay, so that's kind of our finished product. That's how the graphs look. Okay, they have a line and then they're shaded, so it's a whole region. Okay, sorry, getting long here. Let's move on to the next example. If you need any of this, of course, pause. Okay, this one now we have a greater than or equal to symbol. That may change, it may flip, of course, if we end up having to divide by a negative. Let's see. Okay, let's get the y by itself first. So I'm going to subtract 2x from both sides. Okay, I have 3y is greater than or equal to, because I didn't multiply or divide by negative yet, at least. I can't combine these, right? So that's just going to stay negative 2x plus 15. I put the x part first because I know it's like mx plus b, right? Okay. I want y by itself, so the next thing I'm going to do is divide everything by 3. Okay, those just give me 1, and I'm left with y. I divided by a positive, so I don't have to flip the sign. I just carry it down. I'm going to rewrite this next part as negative 2/3 and just leave the x in front. Okay, I'm allowed to do that. That's fine. And then 15 divided by 3, that's just 5, right? So plus 5. Okay, we've got greater than or equal to, so that means we're going to do a solid line. And it's greater than, so we're going to shade above the line. Okay, so y values that are bigger than or equal to the line. So to graph this line, we need to start at the y-intercept. Let me add that in here. So we've got here b is 5, and the slope is negative 2/3. So I start at 5. I'm going to go down 2, and then to the right 3. 1, 2, 3. Okay, if I want to do that again, I guess I can just to make more points. So down 2 over 1, 2, 3. Okay, and I connect these. This time I'm good with the solid line. Oh, maybe. Okay, straight edge would be helpful. Okay, so there's our line. That would just be if y was equal to that, right? We are used to seeing that. This would be the line y equals negative 2/3 x plus 5. But we want the area that's not just equal, but greater than or equal to. So greater than this line, hopefully, makes sense that the area we're going to shade is this region up here. Okay, so that's kind of above the line. Okay, you can focus in on the y values, so it's above here. Okay, which means we shade this half. Okay, so make sure that you have these 2 examples. We'll do some more in class, but at least have these 2 in your notes so you can see an example with an inclusive inequality, and then this last one before, remember, was not inclusive, right? It was the dashed line. So have these both, and I'll see you tomorrow.